Welcome to this episode of Chalk Talk. In these talks, we chat with distinguished teachers of IIT Kanpur on their views on teaching, on the methods they employ in classroom to make their teaching effective, and in general on their views on academic matters. Today, our guest is Dr. R. Sankararamakrishnan, who is a professor of bioscience and bioengineering at IIT Kanpur and is a recipient of Distinguished Teacher Award of the Institute. Shankar, we welcome you to Chalk Talk and thank you for agreeing to share your views on teaching with us. Before we begin, would you like to say a few things to our viewers?
So thank you, Professor Herbola. It's in fact, um, I am very honored and privileged to be here for this podcast, and I want to thank you and also the entire Certex team for organizing this.
Thank you very much.
It's really, very, very special for me. Thanks so much.
Thank you. And it's a pleasure to have you with us. So let's begin with question one. You're from this Department of Bioscience and Bioengineering, which has both the disciplines, science and engineering. How is it different from a traditional biosciences department in terms of thinking, training, and outcome?
Okay. So traditional bioscience departments teach certain disciplines which are considered as bioscience. For example, biochemistry, molecular biology, immunology, microbiology. So these are considered as conventional biological sciences. And bioengineering actually combines biology with other engineering disciplines like biomaterials, biomechanics, tissue engineering, drug delivery, nanotechnology. So this comes under bioengineering.
So the department has a wider scope.
The department has a very wider scope, and it tries to combine both sciences and engineering.
Oh, fantastic. And you've been associated with the department pretty much for its inception. So tell us, how did this department evolve with time and what were your contributions to it?
So the department was established in September 2001, and I joined in April 2002.
Okay.
And when we joined, there were 3-4 faculty members that time. There was no program approved, no MTech program, no PhD program. And we were the first one to finalize the syllabus, get approval from SPGC, and then finally from the Senate. And that's a first step. And then we advertised, we received applications, admitted first batch of students. And the UG program started in 2004.
Right. Pretty much right after the department was
Pretty much
established.
after 2 years.
Right.
After 2 years. So, uh, it and the next most important thing is the faculty recruitment.
Right.
So we made sure that we don't compromise on anything. We recruit the best in the field, and that is the most important thing, that which later defined the department.
Oh, that's excellent, because then I think our viewers will also get to see how a department is established, what all goes into it, and we'll be talking about that. So let's start by talking about the undergraduate program that was established soon, 2 or 3 years after the department came into being. So would you like to share with us what all went into what all went into consideration in designing the curriculum for the BTech program in BSBE, that is Bioscience and
Yeah.
Bioengineering?
So as you rightly pointed out in the beginning, when we decided to start UG program, we wanted to make sure that it's not just yet another, biology degree, usually offered in the university departments.
Right.
So, and in fact, we discussed with several people, including Professor Vijay Raghavan, and with
Who was the DBT secretary later?
yeah. That time he was not yet DBT secretary. And so the main thing is we wanted the student to have a good knowledge in science, biological science, and also we wanted to exploit the engineering environment in the institute. So as any UG program, the students will attend the institute core courses, which includes maths, physics, chemistry, and also institute offers a lot of flexibility for the student to attend engineering courses. And our department also we offered bioengineering courses.
Okay.
So the main aim was at the end of the program, when the students graduate, they should feel comfortable in both biosciences, and they should easily apply engineering techniques to solve some biological problems.
So they have a science background, they are well versed in biosciences.
Bioscience, yeah.
At the same time, they have this engineering mindset
Engineering,
where they can apply.
exactly.
And that is the kind of product you're looking at the end of 4 years
At the
of
end of 4 years.
BTech.
Yeah.
Okay, very well. Then tell me, oh, are there undergraduates that you recall within, you've been in existence for about 20 years now,
Yeah.
2022 to 23, who have made a mark in
Yeah,
their fields, and what set them apart because of this training?
Yes. So one thing is, of course, they don't hesitate to try some new things because they have good background in good basics in biology, and they can apply very novel techniques to solve biological problems. And in fact, in the very beginning, we admitted only 25 UG students. Today, it is almost 55, 60 UG.
It has doubled.
Doubled. And so we have now almost 20 years. The students have graduated. We have a huge list of our alumni. In fact, some of them went on to become leaders in the field.
Oh, wonderful to hear that.
Yeah.
Yeah.
So, in fact, we have students who became group leaders in EMBL, Barcelona, EMBL, Grenoble, and then in fact, one of the best example I can tell is Mohit Jolie.
Oh,
So
I've taught him.
yeah, so you taught. So he's in fact it's the best example where he attended courses from many maths, physics, and many engineering disciplines. And today he's after graduating from BSBE, he went to Texas, came back. He's faculty in IIT Bangalore, and the institute and recognized his achievement, and
very good
he
to
was
hear.
awarded young faculty,
Oh, wow.
distinguished young faculty, young alumnus award.
Very nice.
And he's making, he's working in cancer computational biology, and he is making really very significant contributions. So that's one example. Plus, we have so many other BSB, not apart from academics, many of them, uh, took risk, and then they started their own companies, entrepreneurs. And one of them is a student called Rashi Jain. He started this company called Onco.com.
Okay, so they've gone into become entrepreneurs
Yes,
also.
yes. And then, in fact, it was acquired by Apollo Hospital.
Wow.
Now she is in US now. So there are so many examples, and we are very proud of them.
So the department has really done well since its
It
establishment.
has done well, and it should do even better. Yeah.
Oh, wonderful. So we've talked about UG. I'll come to the PG part a little later. The one question that comes, and you're talking about, they're getting trained in biological sciences and engineering. The intake for students is through JEE,
Yeah.
and therefore, a majority of these students have not had any exposure to biology in their 11th or 12th. So, how easy or difficult is it for them to learn this subject after they join?
I think when we joined, and so even our PG courses were attended by UG students from other departments.
I see.
One of the remarks we always encountered was like we have to memorize a lot, and but then, so if you look at this thick book, you feel that there are pages and pages of text.
Facts.
Yes,
Yes.
but the thing is, you should not view that way. Like even to make one discovery, it years of work went into that. And I used to tell them examples why you are looking at um, the fact that you have to memorize these subjects, because you look at this way. So from one point you reach that point, then the other point. So you are trying to understand what is happening in living beings, and it is not simple. It is complicated. So you have to ask questions. You don't think that you have to memorize. You try to understand what went into that work and what is yet to be solved.
So you made them feel
Yes.
that it is actually science,
Science, yes,
not
exactly.
just a memorizing
No,
of
no, it
facts.
is not memory. It's a very complicated science.
Yes, because there's so many parameters.
So many parameters.
And so many outcomes.
So many outcomes. Yes.
Yes. Wonderful. Now, when something really nice happened when BSB came into being, and that is in the undergraduate review of 2011, we also introduced a core course from BSBE. So tell me, how was it designed? What was its aim? And how have students responded to it?
So the Life 101 course, which was introduced as an institute core course for all UG students.
In first year.
Yes, first year. So what we wanted the students to learn is some basics. It's nothing complicated. Some basics in ecology, genetics, molecular biology, biomolecules.
From scientific point of view.
From scientific point of view. Very, very simple basics. And we didn't make it complicated, because after that, there was the ESO course called Principles of Biotechnology.
Right.
If the students are interested, they are they are free to take other biology courses in the department. So we really wanted to give them a glimpse of just scratching the surface.
Right.
So that's all.
Which was missing before, before that.
Yes, exactly. And several students, in fact, after attending Life 101, and then somewhere in 2015, we also introduced the dual degree program. So
Right.
several students from
Dual degree meaning they do BTech in
BM,
some other department, and then
So in fact, after attending Life 101 and other bio courses, they wanted to do dual degree course in BSBE.
oh, wonderful.
I myself had 2 students.
Oh, that's very good. So that basically goes to show that if we give exposure
Exactly
to students,
Yeah,
they are open to accepting new branches,
definitely.
new disciplines, and so on.
Definitely. In fact, there are so many problems which a traditional biologist will not be able to handle. So you need to apply many different techniques to attack that problem, and that techniques are learned by our
It's
university
a very unique department.
Very unique department. I mean, biology in like 30, 40 years ago was different. But the biology today is very multidisciplinary. And even those who have never done computation, who have never used microscope, they are using this part of their main research.
So that way, in a way, the establishment of this department at IIT Kanpur was a leap.
It is really a fantastic vision for the institute, and it definitely it's a leap. Yeah.
I still recall our Prime Minister Atal Bihari Vajpayee here coming and inaugurating the department, and that was really a very, very nice moment. Yeah. So continuing on this, recently some IITs and IIT Kanpur included, we have also started giving admissions to students who are not taking the JEE route but have cleared Olympiads. What are your views if we take students from biology Olympiads also?
Actually, it is very. In fact, after admission, we have this orientation session, and some students say that we really, I mean, we are not very much into biology, but our parents forced our, we wanted to have IIT Kanpur experience. So, but even for those, of course, many of them, they change their mind after second year, third year. They start liking biology courses. But candidates coming with Olympiad background,
Who had no mathematics.
no mathematics,
Yes.
they are already committed to biology.
Yes.
And learning mathematics, see, for example, I had several, at least a few PhD students who did not have any math background, any computational background. But after IIT Kanpur is such a
We are
good
MTech or PG students then.
PG student, but even UG students.
Right.
IIT Kanpur is such a nice environment. It will be, it's not at all, difficult for them to learn. Especially they can attend this first year institute core courses, maths, physics, chemistry, and they will interact with other students, and so I don't have any doubt that these students will they are already committed to biology, and
And they are very, very good students
very good
because
students.
they gone to Olympiad.
Exactly, and they are they will quickly pick up the concept. They will apply to biology, and it will be a. In fact, I remember in those days, there used to be discussion in the Senate that we should admit students from different channels.
Right.
JEE should not be the only
Oh,
channel.
yes.
So Olympiad is one thing, and then um, I think we also admitted students. We are going to admit students through other channels also. So it's a very welcome move, and I
So
absolutely-
so far, BSBE has not committed to taking students through Olympiad route, and because this has to go through Senate and everything, you know.
yeah.
But your views are that we can take
Yes,
them and train them well.
yes.
They're good students. They'll do a good.
Yes, yes. In fact, we have discussed, and overwhelming majority says that we should welcome this move, and we should admit students with Olympiad background.
Wonderful. So we've kind of covered the students with different backgrounds, how they can really flourish after coming to IIT Kanpur. Number one, because the department takes care of it,
Yeah.
and the IIT Kanpur environment is such that they can pick up things that are missing. So let's talk about, you as a student and a teacher, you yourself had mathematics background and switched to biology. So did you experience any difficulty in making that transition?
Okay, that's a good question. I just want to give a small background.
Sure.
I come from a very, I mean, it's a district called Theni in Tamil Nadu.
Tamil
Not
Nadu.
many people will know.
Right.
Outside Tamil Nadu, but so this I studied in my village up to my schooling was done in 3 different schools.
Okay.
Because my village had only up to 8th class. Then I had to go to the next village to study 9th and 10th. And then all this up to 10th, I studied in Tamil medium. And then my parents wanted me to go to English medium. So I had to go to another town. Um, but throughout this, I had really good teachers who inspired me. In my school, I had a teacher called Sankararamakrishnan and Palnivelu, and then in the college, I went to Madurai. The reason I gave this background is those days government wanted to try this concept of giving autonomy to colleges.
Okay.
So this was one of the 4 colleges.
The Madurai College.
It's called Majura College.
Okay.
There is American college also, which got autonomy, and they wanted to do something different. So they introduced this concept of double major.
Oh,
Yes. So
we thought we were the first ones to do it, but
no, those days.
yeah, yeah.
But maths, physics, chemistry, physics, chemistry, all combination.
Okay.
So I took maths, chemistry, but I mean, initially it was we were told that you can go to MSc chemistry or MSc mathematics.
Right.
So after finishing, I applied to different places, including IIT Madras, for MSc chemistry. But then IIT Madras said you didn't have physics, or you are not eligible.
Okay.
So I ended up doing MSc mathematics in my own college,
Okay.
and but I had a very strong passion for chemistry. So I wanted to do something, uh, some higher studies linked to chemistry. So I applied to IISc, where this department is called molecular biophysics.
Right.
So nowadays you see almost all ISERs, IITs admit students from very diverse backgrounds. Those days, if you want to do chemistry, you should have done chemistry in your previous degree. So they were
IIT was an exception.
IISc was exception, and actually I didn't know exactly what is molecular biophysics that time, but since molecule is there,
Yeah, so you got
what-
chemistry. Yeah, that's it.
exactly. So and this department was established by Professor G.N. Ramachandran.
Right.
With
The Ramachandran plot on
Ramachandran.
triple helix and all
Yes,
that.
yes, exact collagen triple
Yeah.
helix. And I was fortunate that my courses were taught by the faculty members who actually worked on Ramachandran map.
Wonderful.
So Professor C. Ramakrishnan, Professor Sashikaran, it really helped me. My own supervisor, Professor Saraswati Vishweshwaram, she was basically a quantum chemist.
I
So
see.
she worked with John Popple, who
Okay.
was a Nobel laureate.
Yes, absolutely.
And so that environment helped. And she gave me enough time to understand biology. And through coursework, I got exposed to all the biological concepts.
And it was not difficult. You kind of
It was so because of my chemistry background, which I had during my
and also
PhD,
interest in chemistry.
interest in chemistry. So I it was not difficult for me to pick up the concept, and I really enjoyed.
Oh.
At one side, I was I also did very well in my MSc mathematics.
Right.
So I enjoyed writing programs. And
So it was a very nice combination.
very nice combination. And today, it's not uncommon to see a maths or computer science student to enter biology.
Right. In fact, you have a faculty member who was our own
Yes,
BTech computer
yes,
science.
yes, BTech computer science. So in fact, just since you brought up this, Nitin Gupta attended our courses in
when he was doing BTech.
yes,
Okay.
when our department started, and that helped him to orient towards biology.
That's really very nice to hear. Now, what I make out from what you described, I mean, you have been influenced by very good teachers, maybe lucky to have such teachers who inspired you. You also switched from Tamil medium to English medium. You also switched from one subject to other. You went from a college which was in a small town, Madurai, to ISC Bangalore. So you made many of these transitions. How did you take these transitions? Was it any difficult during some period when you were making this transition, or were there people who were helping you? Because this is very important for the students to learn.
Yeah. No, I always get help from others. I mean, one person alone cannot do everything.
Right.
And of course, I can't say that everything was very smooth. I mean, you may have difficulties, but you have to
Persevere, and that's what you did probably.
persevere.
Yes. That's very good to hear. And if you persevere, it pays off.
You
in the
can
long.
succeed.
So how did all these experiences prepare you for becoming a teacher? Particularly, what kind of inspiration do you get from these when you take undergraduate classes at IIT Kanpur, where also we get students from all sorts of background, maybe no exposure to English and things like those, and also a majority of students do not have that biology background.
Exactly. Yeah. So my father was a teacher, and he was teaching for third class students. And I used to watch him, and in fact, he also taught me during the school days. And so, the place where I grew up, teaching was considered as a sacred profession.
Okay.
And
so you had that impression,
I
right?
had that impression, and in fact, my mother always. I got a job just after my college. My mother said that. No, you don't have any responsibility, and this is the age you should study, and you should improve your knowledge. So don't take up that. It's a central government job, secure job, but so
Very far-seeing kind of approach, and another person, a parent pushing you in the right direction.
yeah. So and that helped, and also the environment in IISc, and then I went to Oxford, and then in US.
Oxford was your postdoc? Is that?
Was for my first postdoc.
Okay.
And then I went to University of Illinois Urbana-Champaign, and then I worked as a faculty in a medical school, Mount Sinai Medical School, and then I came back.
Wow, from mathematics to medical school.
Medical school. So each place I interacted with totally different set of people.
And that was very educational.
Very educational, yes. So, and so your question about teaching. So naturally, I thought that the knowledge we have, it has to be passed to the next generation, the younger generation. So I did have second thought to come to this profession. I really liked it. I knowingly I came to this profession, and
And all this exposure helped you in kind of.
exposure helped me. And everywhere I had very good teachers, very good mentors, and I should thank all of them. And so here, the UG students, I had a very high expectation. I come from ISC. I always thought that the IIT students are very bright. So I made sure that I prepare well for my
Right.
classes. And in fact, many students are exceptional. Always ask very very meaningful questions. Mostly I answer the questions, and if I don't know, I will go back and then look at the answers and then come to the.
So that is also a very, very good lesson for young teachers.
Yeah.
If you do not know, say, I
Yeah,
don't
yeah.
know, I'll go look up and
Definitely, yeah.
give you the answer.
Yeah, yeah.
But you also owe that answer to those
Yeah.
students.
No, it's very important that don't just to save your skin, you should not give in a very wrong answers, and you should not mislead them, and you can always come back and then tell them
So
that.
you took name of Dr. Nitin Gupta, who's our own graduate from computer science, and then he switched over to bioscience and bioengineering, and now he's a faculty member in that department. And he took your course. So I'm sure that had something to do with his deciding to kind of switch over to biosciences. Do you think that inspired him?
I think he also consciously made a decision. He had interest in biology, and because I remember he also took an internship in NCBS, National Center of
Okay.
Biological Sciences, and so he used to come and discuss with me during the in his student days. Um, then, in fact, he also made a couple of switches from bioinformatics to neuroscience, neurobiology.
That,
Now he is one of the top scientists in the country.
that is very, very good to hear. And
Yeah.
both from the point of view of our department doing well,
Yeah.
attracting people from different backgrounds, and IIT Kanpur doing well, our students getting proper exposure and then making a choice even after joining as a BTech
Yeah.
engineering student.
Yeah.
So wonderful to hear that. Now, with all this kind of exposure and the kind of students we get, non-biology and students from other departments taking courses, do you make any special effort to make evaluation that to set up examinations where you evaluate students so that best of them comes out rather than what we're focusing on what they do not know?
So one thing is being a good teacher in the classroom. That is one thing. Second thing is, IIT Kanpur always gives freedom to the instructor. Second thing is, you also make sure that you evaluate them well. So the students also should not feel that the instructor is asking this question just to punish us or something. So it should not. They should not feel that one. So usually, what I do, the very first quiz, I intentionally make it very difficult. I give negative marks, and then when they, when I give the answer papers to them back, and some of them have negative marks, but I tell them that this is no way it tells you that you are not good in this course. It only tells you that it's just a warning sign, and it only has 5% mark. And in the
So it's more encouragement rather than saying, oh, you
exactly. So after that, I also tell them no more negative marks
right.
in the coming mid semester quizzes assignments. But it is just to tell you that where exactly you stand. And because many times we teach and then they go next class, before beginning the class, I ask couple of questions from the previous class. students don't answer. So I tell them that you have to, the same day you have to go back and look at what was taught in the class. Otherwise, if you try to do everything just before exam, it will be too overwhelming for you. So many of them, in fact, who got negative marks in the first quiz, they end up getting A star also.
Okay. So in a way, you're helping through this evaluation, you're giving a targeted feedback, what is known in the pedagogy parlance.
In fact, you identify students who are weak, and then you call them separately, talk to them if they have any problem understanding the language or concept, and then I ask them to talk to the other students, or I tell them, you come to my office anytime you want, and sometimes they come.
You're actually, talking about, telling us about why you are a distinguished teacher. You put in so much effort, is it?
I must tell you that when the department started, and uh, all four of us were not from IIT background,
Right.
and how the courses are conducted, how they are evaluated. We took help from the senior professors.
Right.
And I must tell you that they were so kind. They came forward, they helped us. I mean, because otherwise, today, if somebody asked me that question, I will think that, oh, it's such a trivial thing. Why is he asking? But they never mentioned anything. They really helped us.
So that's very nice to hear, because that has been the culture at IIT Kanpur, and I think once you get this help, you give it to youngsters, and then it propagates.
Yeah,
So
definitely.
very, very nice to hear that. Now, you already talked about how you deal with the fact that students feel that biology is a subject where you have to memorize. So you deal with it, but still, when I take a biology course, there is this fear. So one thing is that I'm telling this is scientific, but I also have to allay these fears, the intimidation that you get from the subject. How do you manage to do that?
So the fear is on both sides. The non-biology students having fear that they have to memorize a lot. Biology students having fear that, when you see slide full of equation,
Right,
it will just shut them off.
right, right, right.
So both, we have to handle that. We have to make sure that both feel comfortable dealing with biology for non-biology students, dealing with mathematics.
So this tells me, your courses are basically a mixture of PG students and UG students.
UG students.
Okay.
So, in fact, the current one also is attended by electrical engineering student and material science, chemistry students.
Which course is this?
This bioinformatics and computation. So, I think for the non-biology students to have a fear, so what I do is to simply I don't have slides full of text. So you only tell them logically, and in the body, why is it happening?
Okay.
And why the molecules behave like this.
So one step leads to the other.
One step at a time.
And what about the students with no mathematics background?
No mathematics background for PG students especially. So we have a course, simple basic mathematics for non-biology students. And Professor Neeraj Mishra initially taught couple of years, and then I taught couple of years. Then Anupam Paul, you might know.
Yes, yes.
And he introduced even Fourier transform, all those things.
Mathematics.
Mathematics, yeah. So after attending this course, the students came out and then they said that, sir, we used to think that equation means it's very complicated, but you explain in a way that you make it simpler, they will understand.
Okay. So slowly they kind of warm up to the idea of using mathematics. So you mentioned this course, bioinformatics. This is one of the courses that you teach. The other course you teach is structural biology. Let's talk about structural biology first, because it's very. Is it mainly taken by the students from bioscience and bioengineering, or
actually no. Structural biology courses are, I think the last semester I taught structural biology course, although it's a PG course, but we admit UG students from other departments also.
they take it as an elective?
Elective, yeah. Right. So this is a course which talk about the biomolecules like proteins, DNA, and the idea is if we know structures, we know the function, and the proteins they do all the work in the body, molecular machines. If something goes wrong, it will end up, we will have problems. So, but if you look at the textbooks, they have very nice pictures, but and again a lot of text. So you have to correlate to this. So now, so biology today, everything is available free. You data you generate, the data, the analysis tools, they are available. So
You mean the software?
softwares, databases, and whatever is explained in the text, you simply download the structure from the database called Protein Data Bank.
And you can make it yourself?
Yeah, then you can, then there are tools where you can display these molecules.
Okay.
And then whatever features explained in the textbook, you just show it to them.
Okay.
And then you can rotate, you can translate, you can see how these molecules.
Also, the structure comes alive. You mean.
Exactly. And once they see the structure, and then at the end of the course, I tell them, don't worry about the grades. Next time when you see the structure, you should know that there's something in this structure.
Oh, so that's really nice, because I think visualizing something
Yeah,
and seeing it move, make it dynamic,
definitely.
helps a lot and much better than
Much better.
learning it from a textbook.
Definitely, yeah.
So do you include these kind of problems in your assignments also, where they have to do it
Yeah,
themselves?
yeah. So assignment, for example, I give them a set of questions,
Yes.
and then I also uh, tell them that um, I give one protein to every student.
Yes.
So then there is no question of copying. But I also tell them you can freely discuss among yourself, because they also have to learn from each other. So in that way, they have one protein for themselves, and they can use the tools, and they have to answer set of questions. So that will help them. But I mean, just one protein alone is not enough. They have to practice with several.
So how do you make sure that they've done it themselves and they are kind of learning? Do you take an interview, or talk to them after they've submitted the
So
assignment?
currently, I used to do that, but due to time constraints nowadays, I'm not doing that. But I also have related questions in the exams. So if you have done this, you should be able to answer the question.
Okay, and how do they respond to it?
Response is like they always say that they learned a lot and they enjoyed it.
Okay, and the other course is this bioinformatics and computational biology.
Yeah.
And that also, that by itself, one can see that it must be an very, very interdisciplinary course. It must be requiring
Yeah.
mathematics, this, that,
Mainly probability statistics.
mainly probability statistics. Okay.
So there is an algorithm called dynamic programming,
Right.
and the students who has no knowledge of programming think that it's something to do with programming. So I tell them that it has nothing to do with the programming; it's an algorithm, and but simple things have to you have there is no escape. You have to apply probability statistics. I don't uh, take up very complicated theorems. I only explain a very simple probability, which is just enough to understand that particular.
So tell us the process that you teach in this computational biology or information. I mean,
Okay.
where this is applied.
Yeah.
Yeah.
So, for example, when you want to compare two proteins, and the proteins are made up of amino acids,
Right.
and the amino acid sequences have to be compared. These are nothing but character strings.
Genes, what is it called? Genes? Is that what it is?
Which means
Genes? No, this is not genes.
from gene, the proteins are translated.
Okay.
So, so you are right. So, and then the proteins adopt a unique three-dimensional structure, and that is helping the protein to perform the
Right.
function. So when you have these character strings have to be compared, and then you have to align these character, and how to align. For example, if it is simply comparing to textbook, then it's not a problem. So you see that H and L, they are not same character.
But H and L are two molecules.
True, no, H and L are two characters.
Okay.
But in the case of protein, these are amino acids.
Okay.
So if it is simple text, H and L are different. If it is protein, H is an amino acid, L is an amino acid. H is a basic amino acid, L is hydrophobic amino acid. So you have the match, mismatch, and then similar characters. How to identify the similar characters? And when you align them, this will be considered as probability. Each one will be considered as an event. Probability of substituting this amino acid with this amino acid with this, and together what is the probability that these two will occur together. So there comes the independent events. So we assume that these two are independent. And when you have probability of one event, probability of another event, and these two are independent, you can multiply the probability or combine. So I tell them that I imagine, most of the students are cricket fans. So imagine that you have a rain prediction in Delhi, and you have an IPL match, and when it rains, the match gets cancelled.
Nice.
So what is the probability that there is the possibility of rain today and the possibility of cricket match getting cancelled?
Okay.
So now these two are combined.
Right.
Whereas if I say that there is a higher probability of rain in Rome and in cricket match getting cancelled in Delhi, these two are far away.
Yeah.
They are not going to affect each other. I just give them this very.
So you are also saying that while teaching, you connect with something that they are interested in, and that draws their attention, engages them better, and then you can come to the real topic. Oh, wonderful, wonderful to hear all that. So how, maybe this course must be very popular because, this is math, computation, so students from across the world.
I must tell you that when I joined here in 2002, there was lot of, I don't know whether I should say hype, lot of publicity for bioinformatics, because the human genome
was
sequence
coming,
was. And when I first offered, in fact, many faculty members attended my course. Yes. But then slowly it happened, and then now you don't see that this is the course which is gaining lot of attention, because now everything is going towards artificial intelligence and
But how about using artificial intelligence in this time?
Yeah, that's what we can. In fact, the 2024 Nobel Prize was given to the scientist who developed AI method called AlphaFold.
Or this protein folding.
To predict protein structure, not protein folding.
A protein
Predict
structure.
protein structure.
Okay.
We still have to understand a lot about protein folding.
Okay.
Yeah. So that is there. So if I say that artificial AI in computational biology, then it will attract more students. But currently, it is still bioinformatics and computational biology.
But earlier you mentioned that your structural course is being taken by the students from electrical engineering.
Yeah.
And this course,
Even aerospace engineering.
even aerospace.
Yeah.
So out of interest.
Yeah, out of interest. And this student, I should tell you that the end semester exam, she did not do well. But before going home, she came and then just told me that I really enjoyed the course. So that was really nice for her.
So you said these students take these courses out of interest, but does it also help them in their career prospects in terms of placement and when they apply for higher studies?
Definitely. So, of course, several UG students, a small fraction of UG students go for higher studies.
Right.
And when they do really well. And the courses I teach, they are also very related to pharmaceutical industries, like drug design, drug development.
Right.
That help them. In fact, many students used to go to TCS Life Sciences,
TCS Life Science.
Life
Okay.
Sciences, and then other pharmaceutical companies. And so it at least these courses are closely related to companies. So they really uh, benefit from
Right,
attending these
right.
courses. Yeah.
And suppose somebody wants to become an entrepreneur, have a startup,
Uh-huh.
they also maybe provide basis
Yeah.
in this direction.
Yeah, definitely. In fact, we had like 10-year alumni reunion recently,
Right.
and one of the student who did UGP with me,
Right.
he has started a company which does exactly this, and then he thanked me that your courses helped me.
Oh, very nice.
Yeah.
I mean, you're actually painting a very nice picture about the environment at IIT Kanpur, a broad-based education, a core course in life sciences. So I would really like you to comment upon, and that with this broad-based education that we have, and we try to incorporate the latest into core, does it help students interdisciplinary subjects better, or does it, and also does it help in their future prospects?
So, as I said earlier, biology today is very much interdisciplinary. So, in fact, 50% of BSB faculty members, their background is not biology.
Right.
They come from non-biology background, chemical engineering, electrical, mathematics, physics, and so you name it, and then computer science. So, and interdisciplinary is the buzzword in biology, and
So it's truly interdisciplinary.
truly interdisciplinary, and you have to, I mean, um, especially computation, microscopy, and other equipments, they require knowledge from other fields,
Technical knowledge.
technical knowledge. So definitely, yeah.
So that's really nice to hear, and that also takes us to our next segment, that is PG education and faculty members in
Yeah.
the department, because you said it's interdisciplinary, and I have known that PhD students also come from very different backgrounds, and I've known of
Yeah.
doctors being PG students.
Yeah.
You also have an MTech program,
Yeah.
but mainly we'll focus on PhD, or MTech is also equally
No, we can talk about
talk about both.
Yeah.
So
Mm.
this kind of interdisciplinarity that you have, faculty members from different departments, students coming from very different backgrounds. How does this interdisciplinarity shape research, teaching, and the department culture and thinking?
Culture, okay. Yeah, that's a so to begin with, we are only few now. We are close to 30, and it's very important to have a good culture right from the beginning. For example, in our department, whenever we have SOTA, we have open seminars. Whenever we have seminars,
SOTA means state of the art
state of the art,
literature survey.
literature survey. So all faculty members we attend. For example, I used to joke that I have never attended this many developmental biology seminars in my entire life.
So it's a very healthy culture.
Very healthy, because I also learn. I mean, it's not, should not close my mind that I will attend only the seminars which are related to my field. That will not help me.
Right.
And so we attend bioengineering seminars, molecular biology seminar. Everybody, not just all faculty members and the student. That's a very good culture in the department. I only hope that we continue to keep that culture.
Well, I'm sure you will, because usually one sees when there are people from different backgrounds, there's some sort of a rivalry, and everybody tries to show
So, yeah.
that my area is better than yours. But what you seem to be indicating is that people are really gelling well
But
together.
here the fields are so different. The rivalry has not yet set in.
No, but on the positive side,
Yeah.
you're all gelling well together.
Yeah. No, for example, the the field, if it is really different, I know that the question I am asking is so basic, so fundamental, but still we ask.
Yes.
And the student should be able to explain it.
Right.
So that is why, I mean, that comes with the communication skill, and the student has to make sure that he or she explains it properly, so that my basic question
At your level, they
yes,
will.
that
And yeah, this literature survey and the state of the art seminar are good places to attend to learn new subject.
exactly.
Very, very nice. And with this kind of diversity among faculty members, has it also led to some sort of interdepartmental collaboration in terms of new courses or research, or is it yet to come?
So both inter and intra departmental collaboration. I have many examples. So, for example, BSc faculty members have collaborated with colleagues from material science, chemical engineering, mechanical engineering, chemistry.
Oh wow, that's,
Yeah,
that's
yeah, yeah.
really
So
wonderful.
very,
Yeah.
very good and healthy collaboration. It resulted in very good publications, combined projects, and in fact, in some cases, combined students also.
Okay.
So it has helped, and maybe we have not reached the full potential, but we have several examples of interdepartmental collaboration. Only thing which has not happened is a course which we offer by two different faculty members from two different departments.
That will also come if this much is
It
taking
will
place.
come definitely.
So that's really really wonderful to hear. And we talked about UG students who have done well. Let us now come to your MTech and PhD students. How have they done after they have graduated from here? Your department students, your students, talk
I
about
think
everything.
they have also done exceptionally well, and some of our students are faculty members in IITs, IIT Guwahati, IIT, um, uh, ICERs, different ICERs, NIPER, NIPER Ahmedabad, and BIT Misra, and so many students have gone on to become faculty members in prestigious institutions, and many have gone into the industries. And in my own case, I have students. I graduated 13 PhDs,
Okay.
and some of them are in abroad in academics, University of Virginia, Karolinska Institute, and some of them have come back and they have become faculty members within
Indian
IIT Delhi, BIT Mesra, then Asim Premji University, and many of them have gone into the industries. And
So the institute, the department has really made its mark both at UG and PG level, and the students in both levels have done well.
it has made a mark, but we should not feel satisfied. I think we should try to reach the next level. So I feel that we should never settle for what we have achieved.
No, that's quite a wonderful thought that we should not be just sitting at our laurels, and we should strive to become better and better.
Definitely.
Now, since we're talking about teaching mainly, tell me, and you just mentioned that you have graduated 13 PhD students, and you are a very good researcher also. So tell me how being a teacher helps a person develop as a researcher also.
Yeah. In fact, uh, it's very important that you be a good teacher. And in my particular case, and I have taught this course for a few years, and then I suddenly realized that the very basic, very first chapter in that one, I thought, why don't I apply in my studies?
Okay, your research still.
In my research, and I did apply, and then we published a good paper.
Wow.
Also. So it helps you to good teacher will help you to become better researcher, and a better researcher should
Also
try
to-
to become a good teacher.
Right. So, basically, as a teacher or as a researcher, you're digging out new things,
Exactly. Yeah.
and both help you do that. Just like You mentioned the first chapter itself, you found out something
Yeah.
which you looked into a little deeper and came out of the paper.
Okay.
Wonderful. So let us now talk about the teaching aspect a bit more. And as a teacher, we constantly face this challenge whereby how to adapt to these changing student attitudes. They are changing constantly with time. So I have three questions in that
Yeah.
regard. The first one is, what changes have you observed among the student body over the years, say towards grades, placements, and learning itself?
So just to give you an example of how things evolved in teaching. So when we joined in 2002, all of us came from abroad and we used to use PPT presentation.
Right.
And we did get some criticism that you should not use PPT, you should use
Blackboard.
Blackboard to explain. But then the reverse argument is, how do I draw these complicated protein structures in the Blackboard?
Which you are now using software
Yeah,
for.
softwares for that. But today, if you go to all the lecture halls, so you see that. So we used to carry our laptop and also the projector with us.
Right.
But now projectors are available in every
Right.
lecture hall. So technology has improved and things are changing, and we are also adopting that.
Right.
So
That's the teaching part.
that's
I'm
the
talking about the students' attitudes
students' attitude. Yeah.
toward grading,
Yeah.
placement,
Yeah.
learning.
So, but I may sound like no old person. We always say that during our old days, the students were very. So I don't want to say that students are always. You always find students who are very committed, extremely, motivated, and then there are some students who don't show that much interest. That combination will always be there.
Right. And probably with larger intake, the heterogeneity goes up a bit,
Yeah,
and you may feel disappointed, but it's not really the case. That's
it's
what.
not. I would say that you will. I mean, definitely. I mean, the AI, the internet, everything, and you, as you teach, you see that some student will be still looking at the mobile, and you have to somehow attract. Just mention the name and then ask a question. Student will get, will be little alert, and next time student won't do that.
Right.
But if you have like 600 students, it will be difficult.
Yeah. So a core course in life sciences 111.
Exactly.
It'll be very difficult to
It will
crack.
be difficult.
And that's why tutorials are also important, where
Tutorial.
students by name,
Yeah, definitely.
smaller classes. Now, so you earlier talked about this use of software, use of AI in a very positive way in a classroom, uh, but they also provide challenges in terms of the negative effect on students.
Yes.
They get you just mentioned that somebody is looking at the mobile.
Yeah.
Maybe people are now students are using AI to complete their assignments, and they get disengaged from what you're seeing, or they're seeing so much on the internet. They say, what do I learn from this course? How does the teacher respond to these challenges?
So I want to give one example.
Okay.
Like during COVID, we had this concern. So you were teaching online. Students were all in their home, and but we also had to conduct exams.
Yes.
And there was this concern that maybe the students will look at the online resources to answer questions. But I designed my questions in such a way that unless you understand the concept, it's not available in the textbook.
Okay.
Unless you understand the concept, you cannot get answer in any online.
So you really worked hard on making those tests or assignments.
Yes. So the thing is, the mark distribution was exactly same as the one which I
In-person classroom.
in person also pre-COVID times also. So you have to, this is something which you cannot avoid. You cannot say that don't look at Google, don't look at AI, but you have to come up with some novel way of testing the student, and the student should realize that no AI will help. I have to work on my own.
So all you seem to be giving a message that look, I mean, teaching is a business where you are on your toes all the time. You are thinking, you are meeting these challenges, and you have to put in effort
You have
to become a good teacher
yeah,
and make students learn in a proper way.
definitely, yeah.
And then you can catch them.
You have to
Catch them for learning, I mean.
you have to work on it. So not like just like a standard question which probably you used in the last year.
Right.
But you have to come up with a novel way to test the student.
So, given all this, whatever we have talked about, interdisciplinarity in biology, biology coming up in a big way as an interdisciplinary subject, students, having these varied interests, using AI, getting disengaged sometime, and classes increasing. Which way do you see Indian higher education system going, and is there a course correction required? Or do we need to do something more, something new, so that this large mass gets educated for the future?
So there is no denying of the fact that the Indian education system, for that matter, any education system, course correction is absolutely necessary. Every 5 years, every 10 years, whatever. Um, so, but the main point is. Um, so, what was the first part?
Oh, so the students are getting all sorts of information from everywhere,
Yeah, yeah,
right? And the interdisciplinarity increasing, biology, science being
yeah,
one
yeah.
example. So, and there's so much required, so much needed, or so much expected from higher education. If I can, frame the question further, what course correction do we need, and how do we keep adapting to all this?
So, I think probably the course correction is to look back what the past 5 years, how in each course we have to have a discussion. We have to see how it helped the students and whether the objectives were met, and that has to be done at the institute level. At when we talk about Indian education system, like I am a member of board of studies in couple of universities.
Right.
On paper, the syllabus, everything looks fantastic.
Yes.
So, but they don't have the required number of faculty members.
So delivery is not good.
Delivery is not there. And even during interviews and PhD interview, they will say, "Sir, we have studied this thing," but you ask a simple question, they will not be able to answer. So it has to be realistic when you offer a course, and you have to have the experts who can teach that course. And we also have to adopt the technology and also the changing scenarios. So definitely, for example, we were not talking about AI 5 years ago. Now we talk about AI. So I think all these things have to be taken into account, and definitely when you want to incorporate all these changes, and you have to make sure that you periodically look at your own performance and make the course correction.
So how do we, take care of not having sufficient number of experts,
Hmm.
and can technology help us in that?
So technology can help us. For example, today we have the MOOC online courses, NPTEL courses are
Right.
there. But I mean, how do we, for example, you have to constantly, I mean, I feel that there is no shortage of experts. We only have to find out where they are. We have to proactively look at those people, and not necessarily in India, outside US, Europe, and other
And
places.
have some sort of exchange program.
Exactly. So that kind of, or you have to reach out to them and then make sure that we provide a good environment. We have, the institute gives a good support system, and then you bring those people. I mean, like all these engineering departments in the institute, They are very 50 years, more than 50 years old. And they proactively they made efforts to recruit people, best ones, to be faculty members in the department. That helped the department to make impact in the field.
So that's at the institute level.
Yeah.
If we look at the national level, what do we do? Should we have a program, national program for exchange of faculty, with the universities abroad?
Definitely, I mean, we should do that. For example, the main problem is the universities where you may actually find very motivated teachers, but they don't have resources. And
Okay.
for example, they don't have any means to update themselves. They have to have some kind of training programs and the
And also, I think
institute
the lab facilities are not that good.
lab facilities are not good.
So that brings one question in mind. We are going in this mission mode. We have quantum mission. We have many missions supported by government, which is a fantastic initiative. Should we also have a mission to kind of make labs better, experimental facilities at universities,
Definitely.
national mission?
Labs, it depends upon what kind of labs we are talking about. For example, chemical and biological labs, they require consumables, which are very expensive, which means we need commitment from institute or government that
For that kind of money.
so you have to invest
Right.
on them to have excellent labs. So if we have that kind of at least experimentally, it should be done in some selected places. That will then you see the result and it can be expanded.
How's the financial support at institutes like IITs and ISCs or IIC and ICERs?
ICERs, I mean, the institute, I mean, to my knowledge, the institute is providing support as initiation grant. Depending upon the department, whether they may be really good or it is not sufficient. So, but I must also say that the institute in some cases, help them made extra effort to establish facilities and provided very uh, excellent financial help. So that help. But uh, besides that, if you want to get funding from outside agencies, there are some limited options. So one has to constantly struggle
So there has to be a better support system.
better support.
And beyond the institute, universities have to be supported better.
Universities have to be supported better. Universities, at least some universities have to be identified and
Some sort of center of excellence.
instead of creating new institute, new universities, I think the existing universities should be augmented in terms of facilities. But most important thing is the manpower. So you have to have colleagues, faculty members who are experts, who have the necessary skills, who can who can teach well, who can come up with some good research programs.
Yes.
That's the most important thing.
So we talked about teaching, research, and since this is a talk mainly on teaching, can you recall a moment from classroom which made you feel teaching is really required and it makes a difference?
I think there are several moments, and this one I still remember that he was a doctor, MBBS doctor. He attended my course, and so he after I think I distributed answer papers. He came to me. I was then thinking that okay, he's going to ask me, you have to give me 1 mark to this one. He said, I am not here to ask any more. He's literally, he was in tears that how did I fail to make an impression? So you have taught really well, but I did not live up to your expectation. I said, no, you look at your background, look at you have come this far, it is fine. So the fact that you feel that way itself is it is good. And today, then he went to one of the best engineering schools in US.
Oh, wow.
Now he is a faculty member in US
That's great.
University.
So it's classroom provided that interpersonal interaction
Exactly,
that
yeah.
helped the person.
Exactly, yeah.
Very nice.
Even today, whenever he comes to India, he comes to see me.
Great. So on that good note, we conclude our discussion. And so what I like, I request you to do is give a message to our young colleagues about how to balance teaching and research and enjoy your academic life.
Okay, one thing, I mean, all the younger faculty members, when they apply, they know that IIT Kanpur is a good place. And IIT Kanpur did not become good place overnight. IIT Kanpur is known for its excellence in teaching. And then our students went outside, they made impact, they became, you know, leaders in their respective field. So when young faculty members come, I feel that they should not think that teaching is a burden. Teaching and research go hand in hand with each other. Of course, you have pressure, you have to come up with research projects, get students, guide them, and publish papers. These are all fine, but teaching also has to be taken seriously, and it will really help. And that's a message I wanted to give.
Wonderful.
Yeah.
Wonderful. So thank you for giving us your valuable time.
Thanks to you,
It's
and
been a real pleasure talking to you.
thank you so much. Yes.